So now we're going to talk about solving log problems. Now these are log equations that have log equations on both sides. So on both sides of the equal sign, there's nothing but logs. Everything's logs. That's not very grammatically fantastic, but everything's logs basically. So let's start with something like this. If I told you that log of x was equal to log of 3, what would you say x was? Hopefully you'd say, oh, x is 3. Got it. All right. What if I said that log of 2 was equal to log of x plus 2? What would you say then? What would be x? Probably you say x is 0 because somewhere in your brain you'll be doing this and say, oh, x is 0. Now, these problems can get a little tougher. Say I give you 3 log 2 equals log of x. Now what's x? This might start to give you some pause, but maybe if you stare at it long enough, you'll say, well, you know, I can rewrite that like that, and then I'll get log of 2 cubed equals log of x, which is really just log of 8 equals log of x. So I'll bet you that x equals 8, right? Reasonably confident you could come to those conclusions, right? Yeah. So that's kind of what we're going to do, is we're going to use this basic property that says if we have some log of whatever base of m equal log of the same base of n, then m equals n. And this is exactly what you said over here. You had, remember, you had log of x equals log of 3. So you said, oh, x is 3. Of course, that makes perfect sense. For some reason, though, whenever we start putting more variables on it or making it more complicated, that's when we start to freak out a little bit. But there's no reason to. So our general strategy for these kind of problems is going to be to write each side as a single log. So we're going to write each side as a single logarithm. We're going to set the arguments, for lack of a better word, equal to each other. So we're going to set the m and the n equal to each other. And then we're going to solve and check. So I say solve and check. What do I mean by check? Well, remember, if we have something like this, log base b of m is c, that we said in the last lesson that m has to be greater than 0. So anytime that we are looking at these problems, anytime you get a problem in this whole section or anywhere that has a log in it, at the end of the day, you're going to need to go check your answer and make sure that whatever you're taking the log of is positive with whatever answer you're going with. Okay? So let's look at an example, see if we can get this going. So say we had something like this. Say we had natural log of x plus 2 minus natural log of 4x plus 3 equals natural log of 1 over x. Like that. Now these problems, about the biggest thing that they're going to do is they're going to give you, say that probably the worst part about it's going to be actually solving the equation that you get later. Because you should be really good at writing these as one logarithm by now using the quotient rule. So you've got this going on like that. So you're probably pretty good at that. Probably reasonably or equally as good at go ahead and writing it out like this. But now this is where you might get stuck and say, well, I don't know how to solve that. Yes, you do. You know how to solve this. So take it if you want, a step at a time. Focus on one thing that you want to get rid of and get rid of it. I want to get rid of the whole problem, but that's not an option. So let's say I want to get rid of the x out of the bottom. I want to get rid of this x. How do I get rid of the x out of the bottom? Maybe you say, well, I'll go ahead here and I'll multiply both sides by x. So if I do that, now I've got x times x plus 2 over 4x plus 3 equals 1. Now let's say I want to get rid of the 4x plus 3 on the bottom. So how do I get rid of the 4x plus 3 on the bottom? Going to multiply both sides by 4x plus 3. So we'll go in here and we'll say, okay, I'm going to cancel out my 4x plus 3's. And then I'll say, so here on the left, I've got x times x plus 2. And over here on the right, I've got, I don't know why I didn't see there, but I've got 4x plus 3. Alrighty. Now I can go in here and do x squared plus 2x is 4x plus 3. Go ahead and subtract that from both sides. I can do both of those steps at the same time. X squared minus 2x minus 3 equals 0. So let me go ahead and separate this out. Factor it into minus 3 and plus 1. So I've got x equals 3 or x equals negative 1. So do I get to dance? No, I don't. I have to go back to my original problem, and I have to make sure that x minus 2, 4x minus 3, and 1 over x are all greater than 0. So I have to make sure that x plus 2 is greater than 0, that 4x plus 3 is greater than 0, and that x, or 1 over x, is greater than 0. So let's test x equals 3. Let's go ahead and test that guy. Can you see that? I think I kind of got off the page. Let's try x equals 3. So is 3 plus 2, is that greater than 0? Yes. Is 12 plus 3, is that greater than 0? Yes. Is 1 over 3 greater than 0? Yes. So that's a good answer. Now let's test x equals negative 1. Negative 1 plus 2, is that greater than 0? Yes. Is negative 4 plus 3, is that greater than 0? No. So we've lost that solution. So we're left with just one answer for the problem. X equals 3 is the solution to this logarithmic equation right here. Okay? So let's try another one. This one's kind of along the same lines. Natural log of x minus 3 equals natural log of 7x minus 23 minus natural log of x plus 1. So we got that going on. Now let's try. It's already written as a single log on this side, but over here we can rewrite it using the quotient rule. X plus 1. Now that we have two logarithms, we can set their arguments equal to each other. Now, just like last time, we want to get the x plus 1 out of the bottom. So you see, really, I don't think it's the log part that's so awful. I think it's going to end up being the actual algebra part. So we've got this now. So let's go ahead and multiply it out. First, outer, inner, last. 7x minus 23. X squared minus 2x minus 3. And if I'm going too fast, just pause it. I don't know how fast you need to go. I'm just making some progress. So I'm going to minus my 7x. I'm just assuming that you're getting kind of good at this, because this is pretty much all we've been doing constantly forever and ever. And finally, there we go. Let me go ahead and factor this puppy. We've got a plus sign here, so that means these are both minus. And if I fiddle with it a second, I'll come up with, you got it? Make sure you can do this kind of stuff. 4 and 5. So x is going to be equal to 4, or x is going to be equal to 5. Am I done? No, I'm not. I have to go make sure that this is greater than 0, and this is greater than 0, and that is greater than 0. So x minus 3 is greater than 0. I have to have 7x minus 23 is greater than 0, and I have to have x plus 1 is greater than 0. So let's test x equals 4. Is 4 minus 3 greater than 0? Is 7 times 4 is 28 minus 3 is 23, is that greater than 0? Is 4 plus 1 greater than 0? Yes, so that's a great answer. What wonderful news. And this looks even better. Look at this. We're going to get to keep both these solutions. That's going to be nuts. All right, so, ooh, I'm hanging out with my mom, and she's making something that smells really yummy right now. It's 35 minus 23. It's always nice when someone else cooks, because I can't. Sorry, now I'm thinking about food. I'll think about math. Look, we have two solutions, x equals 4 and x equals 5. Okay? Now, we've had a lot of luck with our solutions lately, so let's go ahead and do a problem where we're going to have no luck with our solutions, because, you know, that's what we do for fun around here, is crash algebra dreams. Okay, so take a look at this problem. We've got log of 4x minus 1 is equal to log of x plus 1 plus log of 5. Alrighty? So we'd like to write this as a single log on both sides. So I'm good on the left. Got log 4x minus 1. Then log of, I can use the product rule. I'm going to go ahead and write that all out. Here's log of 5x plus 5. Set them equal to each other. Alrighty. Gonna move my x's over. Minus 1 equals x plus 5. I'm gonna move my 5 over. And I get x equals negative 6. Am I good to go? No, I gotta check and make sure that's greater than 0 and that's greater than 0. And that's obviously greater than 0. So I've got 4x minus 1 and x plus 1. I want both of those to be greater than 0. So let's test it out for x equals negative 6. Negative 24 minus 1, is that greater than 0? It's not. So guess what happened? What kind of a solution do we have here? We got rid of all the options. We have no solution. So don't be afraid whenever you're working these problems if you get a no solution every once in a while from time to time. It's bound to happen eventually.